Hello everyone, and thanks so much for joining us today. We'd like to welcome you to the Essential Substance Abuse Skills webinar series. I'm Kate Trams, and today we've invited Dr. Ken Winters to speak on the science of addiction, the brain on adolescence. This training series is brought to you by the National American Indian and Alaska Native Addiction Technology Transfer Center, or ATTC. We are one of 4 national focus centers serving the ATTC network, which also includes 10 regional centers and a network coordinating office. To learn more, please visit our website. The series is designed to be a broad overview to assist in preparing for written alcohol and drug certification examinations, to enhance existing knowledge, and to improve overall competence and treatment outcomes. Please be aware that this series is not meant to stand alone, and previous education and training is necessary in order to pass alcohol and drug certification exams. Our center is a NADAC certified educational provider, and CEHs are available on request for a $15 fee. A request form is available for download in the Files pod in the webinar screen, and I will also be sending this form in a follow-up email to all who attended. Immediately following today's webinar, you will be redirected to our GIPR evaluation. SAMHSA asks us to evaluate our events in order to provide improved performance assessment and accountability. This survey asks about your satisfaction with the event and will take less than 10 minutes to complete. We thank you in advance for helping us to improve our programs. You will be muted for the duration of this webinar, so if you have questions about the presentation or about the Adobe Connect system, please use the Q&A pod by typing them in the field at the bottom. We will address questions at appropriate points during the presentation. I will just note that we would welcome your questions throughout. Dr. Winters is planning to keep an eye on questions, so please feel free to submit questions at any time, and Dr. Winters will try to address them as they come in. And we'll also have some time at the end. So if you're thinking about something and want to wait until the end, then we'll have some time then as well. Today's speaker is Dr. Ken Winters. Dr. Winters is a senior scientist at the Oregon Research Institute and adjunct faculty with the Department of Psychiatry at the University of Minnesota Medical School. He has published numerous articles based on his research in the prevention and treatment of adolescent drug abuse and serves on editorial boards for a number of journals, including Psychology of Addictive Behaviors and the Journal of Child and Adolescent Substance Abuse. We'd like to welcome you now, Dr. Winters, and thank you so much for joining us and sharing your expertise with us today. And I'll pull up your slides a moment, and then we'll hand things over to you.
Thank you, Kate. Hello, everyone. Appreciate the opportunity today. I hope you're hanging in there with the polar vortex. I surely can sympathize with you if you're in that part of the country that's getting a blast. So as you can tell from the title of the talk, the focus is going to be on teenagers and brain development. But the complexity of teenage drug use and how we prevent and treat it involves a lot more than biology, and I fully appreciate that. The bias of the 1-hour talk is going to be a little bit more towards the biological end of things. But I don't want you to think that I don't appreciate the extreme importance of context and environment. There are plenty of opportunities throughout the talk where I'll discuss the interaction of brain development and context and environment. But keep in mind, I'm definitely going with a little bit in one direction here today. It's an interesting science, important science. It also is a body of work that can help us with prevention and treatment. So while a lot of the talk focuses on the state of knowledge regarding intersection of adolescent brain development and drug use, hang in there, because near the end I'm going to talk about how we can use and take advantage of this information and use it for prevention and treatment. Okay, so the talk is organized around these 4 topics. The first one is just a very brief introduction to what we know about addiction as a brain disease, at least the portion of that phenomenon that's related to the brain. Um, this might be old news for a lot of you, so I'll go quickly with that section. Then a brief summary of what we're understanding about brain development. That's an emerging science. Still plenty of answers that have to be addressed, but uh, I think you'll find that we're starting to already establish an interesting knowledge base on this topic. Then the third section, I'll look at the intersection of the developing brain and drug use and drug abuse risk. And then in the summary section, I'll provide an overview and some of the clinical implications. A couple good books I like if you're interested in reading more about this topic. David Walsh's book is a very good one, Why Do They Act That Way? He wrote that hoping that both parents and teenagers would read it. And then Anthony Wolf's book is also very insightful. The full title is Get Out of My Life, but First Could You Drive Me and Cheryl to the Mall? A pretty good subtitle. Perhaps soon you'll see what part of the teenage brain, or at least what part of teenage brain development might be at play when teenagers blurt out things like that. Some other resources on this slide. The first and the last one are journal articles. They're actually pretty readable, although they've got some reasonable technical angles to them. The middle two are websites. I think you'll find them very user-friendly. They're intended for non-neuroscientists, for service providers, even parents. Drugfree.org has a very engaging website that walks you through with a lot of interesting animation and video, some of the basics of brain development. NIDA's website is, of course, excellent. Okay, briefly, what do we know about addiction and how the brain is importantly involved in this process of going from using drugs to the point where you show symptoms of dependence? As you may know, the pleasure center of the brain, which is important for reward and motivation and dictates a lot of our behavior, is important with all kinds of reward related type behaviors, including eating and taking drugs. In this slide, it's just showing you with the artist representation of how when you eat food, it activates that part of the brain, and an important chemical called dopamine is key to that activation. And that activation leads to pleasure and the rewarding experience of eating food. Same process occurs when you take a drug. So to the right, you see what happens with this artist's rendition. When you take cocaine, and you can see there's more orange balls or more dopamine activation occurring. So when you have food, particularly fun food like chocolate, you get a nice pleasurable effect. When you take a drug like cocaine and other drugs, you get a very exaggerated response. Some have called it the wow effect. So similar processes in the brain are activated when you eat food and when you take drugs. It's just one is a very normal process, the food eating, and one, however, overexcites in an abnormal fashion that same process when you take drugs. Another way to look at it with this slide, you can see on the far right, upper top, and the middle, you can see the spiking of the dopamine when someone has taken amphetamines. And then below you can see also a similar process, although not as strong, what occurs when you take marijuana. And then I'm adding a third one in the bottom. You can see also a slight increase in dopamine when you're having food. Amphetamine, very strong. Marijuana, moderately strong response and increase in dopamine. Food, that normal level of increase. So one of the problems is not only is there the initial reward with the spike in dopamine, but with continued use of the drug, it looks like what happens is there's a compensatory reaction in the brain that causes your dopamine system to produce less of it, to have lower levels of it. The brain is responding to the fact that you're overexciting the system, and it's kicking in a response by dampening your dopamine production. And this can lead then to the funk people feel in between uses of a drug. And of course, can motivate the person to return to drug use because you want to get out of that depressed or that funk state. So this slide a little confusing, but if you go to the first column of blue scans, and at the bottom it says controls. Those are all individuals that have been scanned, and you're seeing what would be considered normal levels of one of the dopamine receptors, D2, and that would be represented by how much orange or reddish you see inside the yellow-green regions. And you can see that all four people have relatively similar amounts of dopamine levels. To the right, there are four other different people, each of them having been addicted or heavily abused a drug. You can tell by which row they're in. And you can see in all those brains that there's much less of the red and the orange because of the excessive use that has led to a depletion of dopamine production. So people are walking around in a state where they're not feeling their normal self, and thus the cycle can begin of going from just rewarding use to then having to continue to use just to try to return to a so-called healthy mood state, or at least to avoid a negative mood state. So the brain is importantly involved in addiction. Obviously, there's many other factors that can lead you to start to use, and whether you have access and opportunity, that can also contribute to whether you're going to continue to use. But once you start to insult your brain with excessive use and repeated use, there's a lot of biology that kicks in that surely can complicate things for an individual and make it difficult to stop using. The good news is if you can return to a drug-free state, you've got an opportunity to bring your brain back to a more normal functioning level. This slide represents what can happen if you do get drug-free. Across the top is a scan of a normal brain, not a drug-using person. So the more yellow, the more that brain is showing healthy functioning level while engaged in a task while their brain was scanned. The next two rows is the same person who had been addicted to cocaine, and the middle row is 10 days drug-free, and the bottom row is his scan 100 days drug-free. So you can see there's improvement as the person continues to be abstinent from drugs. He's gaining more of the yellow signs of normal brain functioning, but you can see he's still got a ways to go for him to get back to what his baseline would be. You can see there is probably going to have to be continued abstinence. So the person at 10 days drug-free is probably still going to feel that funk. At 100 days, not as much, because there's getting a nice restoration of the dopamine. But the importance of trying to get your brain healthy by agreeing to and abiding by a drug-free plan. So, okay, you've got a little background on the neurobiology underlying addiction. Let's turn to a second neurobiological topic. This is on teen brain development. So I'm switching gears a little bit. The first segment there was about all brains, including teen brains. But let's hone in a little bit more detail about the adolescent brain and what we know. Just some cautions. This is still an emerging science. Many of the studies are based on relatively small samples. We don't know yet a lot about gender and ethnic and cultural differences. Also, adolescent behavior is most certainly directed in part by hormones and important early experiences. So brain development is not the only story. And of course, there can be an interaction between brain development and these other factors that surely can complicate things when you're trying to figure out how much brain development is responsible, so-called responsible for behavior, or how much it might be a secondary factor. Fortunately, there's two major projects underway so we can improve this knowledge base and and learn principles based on much larger samples. One of them is the ongoing project. It's part of the Human Connectome Project. It's called the Baby Connectome Project. So within the larger project, there's roughly 1,000 subjects that are in the youth years, from childhood to young adulthood, that are being studied and looking at brain functioning, behavior, and brain development. Another important one, which is a multi-institute collaborative, is really honing in on the issue of how much drug use may affect cognitive development and including brain development. And this is called the Adolescent Brain Cognitive Development National Longitudinal Study, or often referred to as the ABCD study. And this has plans to recruit up to 10,000 children starting in the late childhood years and following them hopefully for at least 2 decades, maybe even longer. And then the opportunity there would be to assess the impact of drug use on development and functioning. That'll be an extremely important and large database. Okay, so 2 main principles about brain development I will summarize for you. The one principle has to do, well, is adolescence an important period of brain development or not? And it was thought before we had a lot of rich brain scanning data that the adolescent was already walking around with a fully developed brain. And this was probably influenced heavily by the brain weight data that was available. It turns out the weight of the brain pretty much stabilizes right around the end of childhood or early adolescence. And so because that rough marker suggested that at least all the structures were in place, people didn't think there was much brain development after that. But it turns out that wasn't the case when things were looked at with more detail. It was discovered that it was not until about age 25 that the brain finishes development. Now, there's a lot of maturation that occurs by the time you reach 18 or 19, but there are still maturation processes occurring up until about age 25. So a little quiz for the group. I'm not going to be able to figure out who's got the right answers or not, but so who first figured out when the teen brain is mature? So was it neuroscientists using their technology? How about the people that have to figure out who should get a driver's license, or who should vote, or who should have access to liquor or tobacco, or who should rent a car? Who has 25 as a line in the sand? Well, it turns out it's the car rental companies. Now, I'm being a little facetious with this slide. But because they didn't have brain science to inform them, they were just looking at the data out there, and so most car rental companies have age 25 as an age rental limit. As you can tell and think about, many other markers and milestones for youth occur much sooner than that. Access to liquor is 21, tobacco mostly 18, although I know some are moving it up to 21. Voting is 18, access to a car, even younger, 16. So kind of interesting. There is at least one sector of society that looked at data and saw, wow, at least for our purposes, we're going to draw a line in that sand. Okay. The second big principle um, is that the way the brain matures is an interesting way. It doesn't mature in a uniform fashion across regions of the brain. There's a differential maturation process going on in terms of the way the development occurs in terms of structure and processes. And David Walsh has a good metaphor. He uses the brakes and the gas pedal metaphor, and it says it like this: the teen brain is maturing in such a way that the gas pedal is maturing a lot faster or sooner in the teen years, and only until later in the teen years or early adulthood do the brakes catch up with their maturation. And this is phenomenon is represented in this slide. As the areas are getting blue, that's supposed to represent an important brain maturation process called synaptic refinement. And you can see that it's kind of an enveloping process. It's not all uniform. It's mostly front to back. Actually, I should say back to front. Um, but it reflects the fact that not all areas of the brain are maturing at equal levels and equal pace. Another way to look at it is with this slide, because there's two major regions of the brain that are important when we talk about this imbalanced neurodevelopment. The limbic system, or the part of the brain that's mostly in the rear and the middle part of the brain, that has to do with motivation, emotion regulation. It's parts of the brain that help um, uh, drive you to seek fun and to seek rewards. Um, some might call it the just do it part of the brain that tells you to go for it. Um, that matures a lot faster than the prefrontal systems, so mostly located in the front of the brain, and they're involved in um, delaying gratification, resisting impulses, where you do all the heavy lifting of multitasking, more analytic parts of the brain. And you can see that has a more slow, regular maturation pace. So the limbic system is in some ways dominating its maturation and kind of winning out, if you will, and that surely may influence teenage behavior. The prefrontal system, some have called it the seat of sober second thought, part of the brain where your ability to think about something and come up with different options and not necessarily um, go for an impulse is that front part of the brain. Not necessarily the strongest part of the teenager during the teen years. So this is an effort to show you how we might look at brain development and consider adolescent behavior. But a big caveat here, it's problematic to make direct connections between brain development and behavior. But developmental psychologists have weighed in and thought about, well, brain development may help inform how we think about some tendencies during the teenage years. So we have 8 of them up here. They basically are kinds of things that you've seen in teenagers, or if you reflect on your own life, you'd realize, yeah, that was characteristic of me, or I'm better at this now as an adult, but maybe I was not so good as a teenager with some of these things. For example, number 4, novelty. We all like novelty, but the notion is that as a teenager, you're more heavily persuaded to be drawn towards novel things than when you're an adult, where you might weigh many other factors. Number 7, be attentive to social information. Um, all of us are social. We all like social information, but the notion is that teenager is just more dominant in their pursuit of social information, and it may more heavily influence decisions they make. based on social context. The last one, take risks and show impulsiveness, is talked a lot about in the literature. And the belief is that brain development contributes to heavy risk taking and impulsivity in the teen years, more so than would be the case when you're an adult. But I'm going to just reflect on this a little bit with you. Risk taking could be considered quite normative and very important to human development. It might have important adaptive traits as well. So we don't want to think of it as just something negative. When people have looked at risk taking in teenagers, one thing they found is that the deficit is not that teens don't understand the nature of risk, or that they don't perceive the harm that can be linked to risk taking. It has more to do with how they're engaging in risk in contextual situations. So when there's a certain emotional context or there's other pressures at play, it looks like the teenager might engage in riskier behavior than would be the case when you're an adult. One laboratory example of this was demonstrated by Lawrence Steinberg and his colleagues. They were looking at driving behavior, and they had a chance to compare three groups: adolescents, young adults, and adults. And they used a simulated driving lab to measure the percent of risky decisions made and the number of crashes, all simulated variables. And in blue, you can see the heights of bars when the individual was by themselves in the car. And you can see that adolescents, that's always the first bar, had roughly equivalent percent of risky decisions and number of crashes compared to the other two groups. But when you put them with a peer, had them come back to the lab with a friend, and they had the friend sit next to them in the car, you can see that one group now distanced themselves, and that was the adolescents, and they showed the higher rate of the bad driving. The other two groups didn't let the peer effect, influence them in a negative way. So one example, and brain development might be at play with that. So just to summarize, I don't want you to think the developing brain means the teenager has low brain power. That isn't the case. It has really more to do with brain development influencing choices and decisions. And then we also need to consider, and this is what is getting studied a lot now, to what extent is that developing brain perhaps under more influence from the impact by environment, whether it's positive or negative, all the way from trauma to positive experiences, and how might that interact with the development and even alter structure, and of course have an impact downstream. Quote here from I thought a pretty good article from Anderson in 2003. I'm going to read you just starting from the middle. In this manner, the brain becomes wired to match the needs of the environment. Extensions of this hypothesis posit that exposure to both positive and negative elements before adolescence can imprint on the final adult topography in a manner that differs from exposure to the same elements after adolescence. And so one could make a case that early environmental experiences by humans has a lot more impact on your brain and even your future behavior when it occurs during brain development, during the height of brain development, during adolescence, as opposed to that same experience occurring when you're an adult. I'm going to reflect on a good question entered a few minutes ago when I mentioned the ABCD study, and will that study, the question asked, take into account youth trauma and its possible impact? And yes, that study is going to be measuring everything, both biological and environmental and psychosocial, because surely there's important correlations and interactions, and they can have very profound impact downstream. So Section 3. Let's intersect now what we know about brain development and how addiction can be heavily impacted by neurobiological phenomenon. So I'm going to tackle this portion by addressing this question. So are adolescents more susceptible than adults to the effects of drugs? So as humans, we're all in theory susceptible because we all have reward pathway regions and dopamine systems that could, considering individual differences, be hijacked by those drugs, and our dopamine system could be profoundly impacted. But a question would be, well, but is the developing brain or the adolescent more susceptible than adults? I'm going to reflect on 4 lines of evidence with a big acknowledgement to Linda Spear, who's done a lot of great work in this area. And some of the data is going to be based on studies with animals. Mice are used in some of these laboratory studies to try to control for things. And then some of the human data that will be used is has to be viewed with caution because it's very indirect. As you can imagine, you can't study this topic, this question, directly with humans with rigorous research designs. It would be unethical. So I'll occasionally give you warning signs that we have to be careful on how much we can conclude from the data. But let me focus on alcohol first. So what do we know about the alcohol data and what lines of evidence are there? Well, one way to look at it is just, so to what extent do humans use alcohol across the age spans? And it turns out that by and large, for most people, your use of alcohol peaks during the youth years and then de-escalates after that. So at a general level, youth is a period of high risk. It's been shown to be the case with just looking at the habits and the behaviors of humans in modern times. It also is a period where you, by virtue of when you start to use, you may alter your risk of having a problem with alcohol. So this slide shows the extent to which the rate of having an adult problem with alcohol can vary as a function of when you started to use. So to the far left, the bar that says less than 12 years at the bottom, and then at the top it says 16. That means that in this national data set, among those that said they started to use alcohol at age 12 or younger, 16% had a current problem, always defined by past year, with alcohol when they were interviewed as an adult. And then you can see how the rate de-escalates as a function of waiting later to use. So you can reduce your risk all the way down to roughly 2.5% of having an adult problem if you wait till you're 21 or older to start using. That would suggest that youth is a risk period. This slide shows a similar type of data, a little more complicated, but it's showing the rate of having an alcohol use disorder during the teen years among those that used alcohol within the last 2 years of the age that's at the bottom. So to the far left, you have the 12-year-old group. And so among those that were age 12 when they took the survey and said, yes, I've used alcohol within the past 2 years, 7% had a current alcohol problem. And you can see how that rate hangs in there in the 7 to 9% during the teen years, and then it drops significantly. So you go to the far right, the one example there would demonstrate that you're down to about a 3.7% risk if you waited till you were in your 20s to start using. There's also the mice studies show that there could be differential sensitivity to alcohol when you're a young person compared to when you're an adult. One study looks at the acute intoxication effects of alcohol having mice in a water maze test, you can measure how good they're at negotiating the water and finding the platform. And it turns out adolescents, when equally intoxicated as the adult mice, they do it better. So there's other tests that have been done along these lines, but the bottom line is it suggests that at the adolescent level, there's less sensitivity to the acute intoxicating effects of alcohol compared to adults. If you're not sensitive to the effects of alcohol, you don't think you're drunk, it may embolden you to keep drinking. So the extension to humans is that the teenager might continue to keep on drinking heavily, way past what's legal limit and maybe way past what is safe for them, but they don't think they're all that drunk because they're not yet getting all that tired. They're hanging in there, they're not stumbling yet, and so it just could contribute to the excessive amount of drinking in a given episode, in part because they're not sensitive to the cues of intoxication. Then there's the social behavior. As you, of course, reflect on your own alcohol use, most of us become more sociable, and you can demonstrate sociability in mice in the lab. They play fight more, they hang out in groups more, etc. But the bottom line is, comparing adolescent and adult mice, you find that the adolescent mice are more sociable when they're equally intoxicated as adults. So there you have a story that suggests that the reinforcing value or motives behind drinking might be greater in the adolescent than the adult. So it suggests that with these animal studies that the adolescent less sensitive to the negative but more sensitive to the positives. And surely that's a provocative bad formula for teenagers and why they might like to drink a lot. So there's some data to show you on marijuana. Similar type of slide from the alcohol story I just mentioned, showing the probability of having an adult problem as a function of how early you started using, in the same kind of pattern here. Higher probability of an adult problem the earlier you start. The longer you can wait, the odds are you have a lower probability of an adult problem. And this is also that comparable slide showing what's the rate of having a current problem as a function of when you've started to use within the past 2 years. So same kind of story here. In the early teen years, you get a pretty quick onset of use, of a problem if you start to use within the last 2 years. But that probability of having a problem decreases significantly if you wait till later to use. Again, suggesting the youth years is the teenager is very sensitive to the drugs, and they contribute to problems quite quickly, where they don't contribute so quickly if you wait till later. Marijuana and cognitive development is garnering a lot of attention. This slide represents the New Zealand study that came out a few years back. A very provocative study that there's a lot of bars here. The red ones and the blue ones are all below a line that shows 0, and that reflects the fact that when IQ was measured at age 13, then again at age 38 in a longitudinal sample in New Zealand, and they looked at change of IQ and marijuana use, they found a drop in IQ. Now the red bars represent the individuals that started smoking marijuana, using marijuana before age 18. The blue bars represent those that waited till after 18. So the good news is, if you waited till after 18, you did not have a statistically significant loss in IQ from age 13 to 38. If you were a heavy user and started before age 18, you had a significant loss. And that's that third red bar to the right, the longest red bar you see. It represents about a half a standard deviation drop in IQ from age 13 to 38. So early onset and heavy use was a harbinger of of a drop in IQ. This topic will, of course, be a major focus of the ABCD study I mentioned. And others are looking at their data that where they might have cognitive development or IQ data in early childhood or at least preteen years, and then look again later to see if there's a change and if that change is related to marijuana use. I'm going to skip these two slides because they tell a kind of a similar story, but I just want to reflect for you all. It is a complicated topic, and environment may sure have an important role. And how much teenagers learn and how much their cognitive skills develop can have a lot to do with favorable home environments and teenagers who stay engaged in school. A little sidebar on marijuana, since that topic is an important one public health wise, particularly of late. It doesn't take someone who is a political scientist to realize America seems to have started to move into a pro-marijuana phase. This shows how the attitudes of legalizing marijuana have changed from 1969 to 2013, and we've crossed the point, if you look at all ages, where more people favor legalizing it than not legalizing it. There is a big age effect here, but in general, if you look at the population widely, you do see a shift towards pro-marijuana. States vary to some degree on to what extent they've legalized it. This shows you the three ways you could slice up the map of the United States, whether they have medical marijuana, legal marijuana for recreational use, or no laws at all. You could get a little more detailed, and the scoreboard would look like this. So 29 states and the District of Columbia have some kind of marijuana legalization law on the books, so more than half. Now, 8 of them have the recreational use, and with DC. Most of the states that have legalized it have gone with the medical use. But within that, there's great variability, and some of the states are pretty, I guess, lax, if you want to go that way, or at least liberal in access to medical marijuana, which for some equates it almost to a recreational legalization state. As you may know, the last election, there were 5 states that had it on the ballot for legalizing marijuana for recreational purposes, and 4 of the 5 passed it. The potency in marijuana is increasing significantly over the years. The x-axis doesn't have the markers at the bottom, but this at the far left is 1960, and way over to the right is 2011, and you can see the significant rise in the THC percentage, the active ingredient of marijuana that's occurred in the typical marijuana plant. So roughly in the 60s and 70s, marijuana plant might have 3 to 4% THC or active ingredient, and now it's more common to have in the range of 10 to 15% THC active ingredient. And you can use technology to increase that even way past that. But I have up here also CBD, which is the so-called medical component of marijuana, the element of the marijuana plant that may have the anti-pain feature, and may also be extremely important for some of the other medical issues that marijuana can address. And this is kind of thing that's getting studied. Can we take the CBD and extract it and then deliver it in an effective way? But that's a very small percent of the marijuana plant. and it is pretty much stayed at that level. So medical marijuana, if it's smoked, you're basically getting a lot of THC, your active ingredient, at the expense of getting only a minimal amount of CBDs. Hopefully, we'll see the technology come to the point where the good stuff in the marijuana plant, at least the medicine part of the marijuana plant, can be extracted and delivered in effective ways. And it is getting studied. So we want to keep watch of that. There's some, pills and oils that are looking at that. My last sidebar is just the connection between marijuana use and mental illness. There was a great review coming up by Cynthia Miller that will occur in a book hopefully published soon in 2017. And she reviewed the possible connection between marijuana and mental health. And I've had a chance to review the chapter, and so I'm summarizing it here in a lot of different ways. But she reviewed both cross-sectional and longitudinal data, and then she looked at various disorders, and then was able to describe whether there were a lot of studies or just a few studies. So if you look down the two columns of cross-sectional and longitudinal, you either see no plus mark, a single or a double. So no plus mark meant there was no studies. A single plus mark meant that there were a handful of studies, and the double meant that there were several studies. And then you can see the 5 disorders. So this chart would tell us that the most data is focused on the potential of marijuana to impact schizophrenia. And that's got the most data. But you can see bipolar, anxiety, depressive, and risk of suicide are also in the literature. And then I boxed in 3 of them. I put the box around those 3 because Miller's claim is that there is provocative data to suggest that the risk for these disorders is significantly elevated if the marijuana use occurs when you're a young person. So it's another youth angle. Marijuana, youth, and perhaps a propensity for a disorder is a bad mix. Here's her concluding quote: "The preponderance of evidence reviewed in this chapter substantiates not only a significant causal role for marijuana in chronic psychotic syndromes, but also a strong association with mood disorders and suicidal ideation." Schizophrenia being the most significant, and but other disorders also in the mix. Okay, back to these 4 lines of evidence. There's, I think, some interesting convergence of the data, and I think it suggests that youth is a vulnerable period. But an important question is, why is youth more vulnerable? Why is there a higher risk for drug problems if you use during your youth years compared to later? Is it 4 alternative explanations, and they might all be part of the mix, or some might dominate over others. There could be inherent risk factors of brain development that contribute to drug use. So remember, a brain development might contribute to certain tendencies in the teen years. These tendencies might contribute to increased curiosity to use, or the motive to keep using, even in the face of negative consequences. You've got social phenomenon, you've got novelty, you've got interest and excitement, the willingness to take risks. All these might be basically a psychosocial mixture that contributes to onset and use. Adolescents, as adults, have pleasure centers, and these pleasure centers can get hijacked by drugs and create the nasty cascade from use to dependence. So just that basic underlying phenomenon might be at play. There's also a related issue, and that is that the teen's pleasure center might even be more susceptible to drugs than adults. There is a school of thought that dopamine activity during the teen years is what's called more robust, which in some ways is saying it's just more sensitive. So That might mean that the initial experience of drugs, you get even a bigger wow effect than if you were an adult. That might surely then increase motivation to keep using and lead to more difficulty in stopping to use. The belief is that the dopamine activity may be more pronounced when a given dose occurs for a teenager compared to adult, and so thus that could surely lead to more reward, more continued use. And then there's the concern that early use may sensitize the brain, and so that just continues to lead for the person to keep using and contribute to biological processes that um, increase probability of more use downstream. The concern is that early use um, may recalibrate the brain sensitivity to the drug of abuse and to other drugs. And so with a highly sensitive brain and with opportunity, you could see that could contribute to more use. Okay, let me summarize um, and also include uh, some clinical implications, and we'll have some time to discuss. So hopefully you appreciate the fact that adolescence is a very interesting period of time. Normal adolescence is characterized by many behaviors and traits that may frustrate parents and counselors and teachers, but they are normal, and most of these traits are things that young people grow out of. Um, the brain development is not uniform, and the last part of the brain to fully develop is what's called the prefrontal cortex region, the part of the brain that's mostly involved with judgment, decision making, impulse control, and thus it can be a time of one's life where you're challenged to avoid making bad decisions and doing unhealthy things. I think there are several lines of evidence that suggest, it's still at the suggestion level, that adolescents are more vulnerable to the effects of drugs, particularly alcohol, than adults. Um, and these lines of evidence are indirect, but they come from the animals models and from epidemiological data. So um, I I think this body of work though can be used to help in our prevention and treatment efforts. For one, it surely reinforces the need for prevention and treatment. Um, if youth is a particularly vulnerable period, that means we have to uh, definitely place a high priority on prevention programs. Treatment is important because even though use might have started, even though there might be dependence, uh, the healthiest path for a young person is to get to a drug-free lifestyle and get as much normal maturation back at play. Um, we think it's informative to educate teenagers about the neurobiology of addiction, and because it's not just a willpower issue, there is a lot of biology involved. And if a teenager passes a certain tipping point, it can be very difficult to stop using. And that probably isn't, something in the knowledge base of most teenagers. So teaching them about neural pathways, reward systems, how dopamine, an important chemical to regulate your mood, is all part of the story. And by taking drugs, you're at risk for altering it in significant and negative ways. And then there's the whole topic of educating teenagers about brain development and the importance of doing what they can to have a healthy um, trajectory during the youth years, and how drugs are most likely going to negatively alter that. Now, the dramatic New Zealand study of half a standard deviation IQ drop is pretty provocative, but getting teenagers to realize it may also impact on their short-term memory, ability to learn, ability to function socially in ways they would like, because they might be doing some acute damage. Um, we also think the prevention and treatment programs that teach important skills that the teenager is at the front end of learning, and um, and skills that are not necessarily optimal because the way that brain is developing is the way to go. I've listed 5 ways of looking at it, all the way from the standard impulse control and better decision making to teaching teenagers how to take healthy risks. I think if you look at the evidence-based prevention and treatment programs, you'll find that do a great job in addressing these. I'm encouraging people to make sure that if you use programs, um, review them for their their focus on what I'm going to call these decision-making skills, and 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 make sure that those become an important part of the of the curriculum. If you're wanting some classroom resources, if there are any teachers out there, there are a couple ones you can do some homework by going to the websites. These are 2 that I like. The first one is more lengthy, and the Hazelden one is less, only 8 lessons, but both of them are an effort to get science teachers to teach youngsters about not only the science of addiction, but also brain development. And then for parents, I point parents to a lot of resources. You may know there's just countless websites for parents, for parenting practices, etc. There are this one I really like a lot. It's the drugfree.org. I like it because it not only has information about prevention, but if you think your teenager's already started to use and may even need treatment, they've got some great tips and resources for you as well. As I mentioned way back, they've also got a nice segment on teen brain development. We use this worksheet a lot with parents. Feel free if you want to. So each letter of the word parent has a phrase or a word that is a lesson that we hope they can take forward in promoting health and well-being in their teenager. It's a mix of a little brain development, drug prevention, being a good parent, and we get the parents to reflect on each of these and come up with examples or ways they could do it, how they can polish and steer their parenting along the line so they can raise a drug-free child. PARENT. Promote, assist, reinforce, encourage, never underestimate, and tolerate. Tolerate oops behaviors. Oops means the kind of thing where a teenager might get a little too emotional. You don't want to let that get the best of you. Okay. Thank you for this opportunity. And Kate, I can just jump in with one of the questions that's on the board here. There, Victoria raised a good question about predisposition and for a mental illness and marijuana use, and Miller's chapter I think supports that position that probably the biggest risk is if there's an individual with a genetic predisposition for some of these disorders and then uses marijuana, it likely alters significantly the likelihood of having that disorder, or alters the severity of the disorder. I don't know of any sound body of literature that suggests marijuana use would literally cause mental illness in a person that didn't have a predisposition. That's probably a more controversial topic, but I know it looks like the science is indicating that it's an interaction of predisposition and marijuana use.
Thanks so much, Dr. Winters, and yeah, I would encourage everyone submit some questions. We have some time to take a few questions, so we'd love to continue the discussion for a little bit longer. If you are having trouble finding, the Q&A pod is just to the right of the the screen, there should be a field at the bottom where you can type in your questions. If you are calling in, we unfortunately don't have a way to get questions through the audio, but you should be able to type them in.
Amy asks, is there a website I can download pictures of brains developing on and off of drugs? I'm going to do some homework on that one. I don't think I've ever seen one that good, but I'll send to Kate the if I find something, and she can forward it to you and the others.
Great, yeah, I will definitely send it on if we find a good resource for that.
I think one of the problems is going to be, I'm already reflecting, the ethics of trying to get that data is problematic. So there might be animal models, though. Well, we'll have to look. Oh, by the way, I should say the ABCD study is it will be scanning youngsters in that study periodically throughout their involvement. So to some degree, when that study has got enough years under itself, they'll be able to show the trajectory of brain development of youngsters, that haven't used, and then trajectory of brain development for those that did unfortunately start to use drugs. And the one good part of that study is a subset of it will be twins. And so it turns out even identical twins, some of them use and some don't. And so you have what's called discordant twins on drug use. And that'll be pretty powerful to see what that picture looks like with the sets of twins that, or the individual twins that don't use versus the twins that do. It'll be a little clearer about to what extent the drug use influence the brain development when you can use a twin model.
Great. I see another couple questions in. A couple of people are asking about a copy of the presentation. We do have handouts of the PowerPoint that they will be emailed to you, but you can also download them in the Files pod, which is in the lower left-hand corner of the screen. That should open up another browser window, and then you should be able to just X out of that and come back to the webinar. But also know that it'll be emailed to you if you don't get a chance to download it.
Monica asks, what approach would I recommend for treatment of an adult which began methamphetamines at 13? Well, good treatment, something rigorous and something probably long-term. That might be an individual, particularly if they're still using, that's going to need to get serious about, a commitment to long-term recovery. I don't know if I don't think any particular treatment out there, treatment approach has been able to document it's the best or better when it comes to this kind of drug problem. But but it sounds like it's going to need something in the intensive end of things as opposed to non-intensive. Victoria asks, is there research about how marijuana use may inhibit brain structure development? With legalization, and research still coming on, will there be regulations? So I think the concern is that it may alter brain structure in significant ways, and that alteration may lead to cognitive problems, cognitive development problems, which could be lower IQ or poorer memory, poor attention, etc. So now in terms of structure, I haven't seen anything that's compelling at this point. But people are worried about it altering in negative ways. And like I say, it's still early. We're going to know more after these major studies are done because we'll have larger samples. But there's, marijuana is a very powerful drug because we have cannabinoid receptors in all over our brain. That's why when you're high in marijuana, it affects so much of your behavior, all the way from appetite to social behavior to coordination, etc. You're not a better driver. It's not a good drug when you're driving, and it surely can impair judgment. Um, and of course, there that is the big concern with youth tending to now believe it's less harmful drug than they have in previous years. That they'll even in states that are trying to restrict its access, uh, the concern is the youth use will rise, and this will occur without a lot of uh, public health warnings sticking with people. Um, and I'm always impressed and disappointed how many politicians seem to have bought into the legalization uh, notion when I just don't think it's very informed. That's a bias I have. I think I've got data on my side, but I can appreciate that there's other points of view. Is there a particular mental illness that you've recognized to be more prominent to addiction? Is asked by Delicia. Well, with teenagers, there's I think if you ranked ordered co-occurring disorders, you'd probably ADHD and conduct disorder would be one and two or two and one. Um, but affective disorders also, of course, emerge. Youngsters with PTSD, those are also associated. Um, when you look at adult populations, I know antisocial personality disorder definitely shows up, at least in the alcohol literature. But there's plenty of people that, of course, get involved in drugs that don't have a what you might call a bona fide mental disorder. All kinds of risk factors um, and other motives can drive it. Amy asked, is there evidence on cognitive behavioral therapy being effective in treating addiction? Monica may want to investigate this evidence-based therapy. I'm a huge fan of CBT, especially when it's combined with motivational interviewing skills in the counselor. So, Amy, that's a good answer. If I were to choose a treatment program for someone who had a serious drug problem, I don't, not that I wouldn't um, uh, uh, avoid a 12-step program, but I would want a program that where its counselors had strong CBT and motivational interviewing skills. That could be done in a 12-step, but I'm perhaps like Amy, I'm a big fan of that approach. Candace says, I found Hazelden's Drugs and Developing Brain, which appears to be a PDF that references slides and shows the students. Are the slides available on Hazelden's website? Okay, good. Hazelden has, yes, Drugs and Developing Brain um, uh, 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 CD, and it has, yes, it's this is actually there's two of them from Hazelden. So Drugs and Developing Brain is the classroom version that is got all kinds of resources for the teacher, including slides and activities and mini clips. So, but Hazelden also has another DVD series that covers brain development and treatment, a broader resource, but all on adolescence. It's very engaging, and it has four components. Um, some of it would be great for a classroom. I think that the drug addiction, the neurobiology of addiction would be good for a science class and brain development portion. But then if you have youngsters that are in treatment, there's a couple sections that are very helpful for keys to recovery, keys to long-term success, things of that nature. I don't have can't remember the name of it, but if you go to Hazelden's website, look in their DVD series, you would see that second one. Christy says, when meth first started surfing, um, research was shown that at the time a teenager started using that is where the brain stopped developing. Oh, is this still true? For example, teens started to use at age 14. Do they still function as if they're age 14, even though they might be age 40? That's a great question. And there isn't, from what I can tell, hard science on that. But if you start to connect some dots where, so you've used drugs at a young age, that narrowed your experiences, and you lost an opportunity to learn a lot of social skills, and you maybe even had some, negative impact on future learning. You didn't catch up as you got older, and so at age 40-ish, you may still look like you're relatively immature. I could see it working that way. I don't know if it necessarily halts development. Keep in mind the brain is always, in many ways, micro ways, developing. Cells are growing, new neurons are developing even past age 25. This is all part of normal brain activity. So, but surely, someone who's heavily used drugs as a young person, they might have really missed out on a lot of opportunities, and maybe that's what you see manifested in adulthood. Okay, that's good. Kristen says state-dependent restriction would fit in with older adults acting like teens if they started using during their teen years. Okay, very good. Danielle, with the theory about impact of environment on brain development, should we put more resources towards family engagement and adolescent treatment? Yeah, the other thing if I had a teenager that needed treatment, I would not only like a program that has CBT and motivational interviewing, but also a family component. So there's reasonable data out there, from what I can tell, that if you have a family component, at least some portion of the treatment program, including the family, included in your program, you will have greater outcomes on average than if you didn't. And the family could be extended family. And I think it's so helpful because it does help, improve the environment, or at least it gives the opportunity for the therapist to work with the whole family on what they can do to soften and optimize the environment to support recovery. So, and one other feature that's important, and the family can be, and particularly parents can be important with it, is peer influences. So during the teen years, there's probably a big shift where peers are influencing a young person's behavior more so than parents, and not a news bulletin if you've raised teenagers. But that doesn't mean parents are out of the mix, and where, to the extent parents can steer their teenagers toward or away from the good, toward away from the negative peer influences, the better. And that's such an important thing for parents to talk about and get some strategies, because they may feel helpless, but that is a flex point in rearing kids you don't want to give up on, even though you might feel pretty frustrated by it.
Well, it looks like that is all the questions we have. So just want to thank everyone for interacting with us and for bringing great questions, and want to thank Dr. Winters. Sorry about that. Want to thank Dr. Winters for your excellent presentation and just bringing so much knowledge about the brain and helping us understand how we can help the adolescents, whether we're treating them or just people in our lives. So yeah, I would just want to thank you again. And is there anything final you want to say before we close out, Dr. Winters?
No, just people can email me if they have something they want to follow up on, they didn't get a chance.
Wonderful. Thanks so much. And we did get one other question about whether the lecture will be available. We did record today's webinar, so we will be sending out a link to the recording to everyone who registered. And so you can view it again. You can share it with colleagues. Yeah, we'd love to to have you share that. And yeah, please get in touch with either Dr. Winters or myself if you have any additional questions. And with that, I will wish everyone a great rest of their December. Hopefully, we'll see you all back. We'll be sending out announcements of our January webinars within the next couple of weeks. So hopefully, we'll see you all after the holidays, and wish you all many blessings. And thanks so much again for joining us.